Chris Biscardi, the man, the myth, the legend.
There he is. Yeah.
I bet you his mic isn't working.
It's working, I think.
Oh, there he is. Oh, wow. Hey, dude.
I'm just turning you off on the stream because now I'm hearing you twice.
You might notice that Chris is wearing an awesome tank top with rainbow corgis. That is his sort of brand, the Party Corgi. So take it away, Chris.
Thanks, y'all. Appreciate that. So yeah, I'm Chris. Thank you for the introduction, Ryan. Appreciate that. And this is going to be a little bit about what comes next in terms of, well, I'm about to tell you. So, and this is going to be a talk a little bit about building product in React. So I know we could have like a what comes next talk about how we build our libraries better, or like how we do, I don't know, Redux architecture, which isn't like a thing that most people do anymore, or why we're using whatever library today, right? State machines could be in this talk. But this is really going to be about a little bit of history, a little bit of the current day, and what we could do in the future in terms of the tools that we use that enable us to build better products over time, right? And so somewhat obviously, this is going to be from my context. So I'm going to interject a little bit with stories from my past over the last 10 years as we talk about the history, and then move into the current day so that you have a little bit of context for when I say this is what we're doing in the future, you know where I'm coming from. I'm Chris Biscardi. You can find me on Twitter at Chris Biscardi. I have a Discord server for the wonderful Party Corgi network. That's at cjb.dev/discord if you would like to join that. You may know me from having worked on Gatsby themes or gatsby-mdx recently. I'm an independent consultant, and what I do is basically R&D for startups based on open source technology. So working with companies like Docker, working with companies like Gatsby to develop new products and get them shipped. So a lot of my context comes from new products, greenfield work, rather than maintaining 10 or 20-year-old projects. Which, I mean, React isn't even 10 years old yet. So hopefully nobody's responding to job applications for, 10 years of React experience. So we're going to start with JavaScript, right? JavaScript, the language. And JavaScript today is a lot different than JavaScript of 10 years ago, or JavaScript even of 5 years ago. And we're going to take this to paint a little bit of a picture about where we've come from and where JavaScript is going itself. If you are unfamiliar with jQuery, that's where this story starts, right? And it starts with jQuery because if you see the wrapping function here, and you've started programming within the last 5 years, you've probably never used this wrapping function. And this wrapping function is called an immediately invoked function expression, or IFE, which is what everybody used to call it. And the reason for this sort of wrapper boilerplate around document.ready, which is a jQuery API, is that we actually didn't know what that $sign was going to be when we used it. So we kind of needed to wrap everything and pass jQuery in and define it as the argument to the function when we went to use it, because we didn't have modules, right? It's sort of like this immediately invoked function expression is the discount Mark Ruffalo of like JavaScript modules. We didn't have anything better. And then Node comes along, and let's see, I learned JavaScript maybe a year or two, maybe 3 before Node came out. And I had a client that was lucky or brave enough to deploy Node 0.2 to production, which was amazing. But really what Node did for the wider ecosystem is give us a set of standards that we're sort of grateful for, but also still using today, right? Like, for example, Node gave us NPM over time, and NPM has been great, but we're also now stuck with NPM. It gave us CommonJS modules, which were great at the time, better than anything we had really, but we're also stuck with CommonJS modules now, in some sense of the word, right? And like NPM and CommonJS modules are part of the reason that we need bundlers at all today, right? we can't statically analyze common JS modules. The Node ecosystem and NPM and the NPM registry was something that everybody wanted to use when we went to build like React apps, right? And even before React, we wanted to use this NPM registry to share code with people. And that led us down a path where now common JS is very firmly embedded in basically everything that we do in JavaScript. So if you've never seen common JS, this is what common JS looks like. It's a module that exports equals whatever. There are a couple different ways to write this. This is just a simple function that multiplies a number by 2. And common JS originally was sort of competing with another spec called AMD and a library called require.js. And basically, like require.js was sort of like one end of the ecosystem, and common JS was the Node and the NPM people. And it just so happened that we found a way to bundle NPM packages before we found a way to ship everything to the browser like we have maybe today. So the standard of common JS sort of took over. And this was sort of a dead period of JavaScript language evolution, right? Because eventually, over the next like 5 years or so, from 2010 to 2015 or so, there wasn't a lot going on. Like ECMAScript 4 didn't really happen. And ECMAScript 2015 gave us things like JavaScript modules, like actual JavaScript modules, which, of course, you may be using in your applications today. So what we call JavaScript modules are ES modules, right? You do an import, maybe you do an export. There's a couple different ways of doing these. There's a couple different specs these days for imports or export from and things like that. But the browser doesn't understand this syntax. And the browser doesn't understand this syntax because we had to have parity with the way that common JS was doing things. So if you import React from React, that's a common JS module name, right? It's an NPM package. The browser doesn't know what an NPM package is. So this doesn't work in the browser, even though the syntax looks very much the same. And that's sort of some of the legacy baggage that we got stuck with from common JS. And it makes it a little harder to move the ecosystem forward towards ES modules. So I'm suddenly realizing that this page makes my entire face glow yellow. So here's Babel. So Babel came on the scene as 6 to 5, and it was a way to take this import, export, and all of this other syntax, and basically compile it into something that was usable today. That's not necessarily what it is anymore, right? It still is that at its core, but what it is in a greater sense is the way that the JavaScript ecosystem develops JavaScript itself, right? If you want to go to the TC39 and you want to say, hey, I want to add this to the JavaScript language, people are going to end up asking you, where's the Babel plugin for me to test this? So we'll never really get rid of Babel, right? Because it's so embedded in the development of the actual language at this point. Which means when we look to the future and we look at sort of bundlers and things like that that are using the new ES module syntax, we see URLs instead of package names, right? The second example on this page is import React from web modules React.js, and that is actually a Snowpack-ism that we'll talk a little bit about Snowpack later, but basically we're importing from URLs, right? Like Deno, or Deno, actually, don't know how you pronounce that, is an alternative to Node, right? If you look at the name, it's Node shifted by 2 letters. It supports TypeScript by default, so we can just import TypeScript module definitions from a URL. And this is what works in the browser, which means that we have to take a step forward from where we are today with common JS into a world where we can actually get ES modules for all the packages that we use. Because if we just use it in one file, it doesn't matter. We have to use it everywhere for it to really have a large impact. So today we use Webpack, right? Webpack is basically the standard for the React ecosystem. There's a couple other bundlers and things like that that come out, but we didn't always think of bundling as this like really big, heavy process, right? In the beginning, we basically just took any JavaScript that you wrote because you were writing ES3 or ES5 or whatever it was. We concatenated it together into one giant file. We manually minified that with something like uglify, and then we just shipped it to a directory. And we sort of did all this manually, right? You can see here that we're specifying like in the source directory, take all the JavaScript files, put them together, and then make them smaller. And this is done with like Gulp and Grunt and maybe custom scripts, right? And then we hit Browserify. And Browserify is the first tool, or one of the first tools at least, to operate on the idea of a module graph, right? So we don't necessarily need to say, give me all of the JavaScript files in this directory anymore. We can say that the entry point to our application lives here. And by the way, we've written it in CoffeeScript. And by the way, we've used some syntax that we need to compile with Babel. And then after Browserify, Webpack comes on the scene. And Webpack is basically Browserify 2 for all intents and purposes here. It has a stronger definition of the module graph. It's extremely pluggable using a bunch of plugins. And it's used these days by all of the major frameworks, right? Like Create React app, Gatsby uses it, Next uses it. Basically, everybody that lives in the React ecosystem and builds a meta framework, which is what I'm calling that group of libraries, uses Webpack to do something, right? And it gives us a lot of really nice things because we get things like dynamic import syntax and the functionality to actually use that behind the scenes without having to worry about, actually including a library to do that because Webpack handles stuff. But looking forward into a little bit of the future, when we were talking about ES modules before and sort of how we went through the JavaScript language ecosystem evolution, ES modules need to be sort of first class by default, right? And Rollup does that. Whereas Webpack has support for CommonJS because that's the ecosystem it grew up in, and then added ES module support later. Rollup is all about ES modules, right? You don't get CommonJS exports if you don't include a plugin for CommonJS exports, right? And this allows us to do things like tree shaking, right? Which is super nice. On top of that, people are building new tools, right? New tools like Snowpack. And people are sort of frustrated around maybe the build times of Webpack, right? For example, Gatsby, for one, kind of takes a long time to build sometimes, right? And Gatsby is built on Webpack. And a lot of people have trouble with sort of manually constructing Webpack configs and things like that, right? So Snowpack is sort of a step in the opposite direction back to this script concatenation. Except we don't need to do script concatenation as much anymore because we have ES module support in the browser, which means that all we need to do is make sure that the NPM packages that we install, right after we install them, get converted to ES modules, which is this process that you see on the screen right now. It converts node modules, which are the NPM modules, into a web modules folder, which is where the ES imports come from. And this makes it much faster to do some simple development, right? We can completely get rid of Webpack for basic usage, which is a really interesting step. And we're nowhere near sort of the end of this, right? I think that we'll always have these meta tools on top of Snowpack or on top of Rollup, which Snowpack is built on. But this is where we're headed. We're headed towards an ES module future. And that means different things than what we have today. And then even Node gets ECMAScript modules, right? Node v13, I believe, unflagged Node modules. And yeah, okay, they're experimental. And yeah, okay, they're not quite supported as well yet. And the version that's in the browser, where you import URLs, and the version that's in Node are different. And the version that's in Dino uses URLs, but the version that's Node doesn't. So there's still a lot of compatibility issues there. But ECMAScript modules are definitively the future at this point. And the future is sort of like here. So let's go from that into how we deploy our applications, right? So what happens when a user has one hand and they're in the kitchen and they're holding their kid with the other and they're trying to use your app with the other? And can they do that? What if the Wi-Fi goes out, right? How are we deploying these things? How are people using them? How can our apps meet people where they are, basically, right? And in the past, maybe circa 2010, we're still doing a lot of Rails stuff. We're still doing a lot of that kind of deployment, right? Where we take a server, we ship it, it's running somewhere. Somebody has to have an active internet connection to get our website from that server. They get our website from that server. Maybe it has a sprinkling of JavaScript on it, right? Because we don't have these complex build tools to build giant JavaScript apps yet. And they still have to have that connection anytime they want to do anything. If they want to submit a form, they have to have a network connection. If they want to go to the next page, they have to have a network connection, et cetera, right? So then we start moving in more and more of a fat client direction, as what it was termed at the time, right? We go from server and client to single page application, right? And that starts making us ship more and more JavaScript. After single page applications, we kind of went to progressive web applications, which, not everybody still uses yet, but exist. And there are a bunch of APIs that help us do things in a progressive way. And then we minted a new term called Jamstack, which, if you think about what Jamstack is and how we do deployments from this client-server model, the Jamstack represents a move from client-server and running an actual server to taking static assets and pushing them out to CDNs so that your app is very close to your users, right? If you have a server and you have a server in US East, maybe everybody at this meetup can access it super, super fast, right? US East 1 is pretty close. But if I have a server in India or I have a server in Hong Kong or Singapore or anything like that, you have to travel around the world to get there, right? So with the Jamstack approach, we've shifted from client and server, running server, to take my assets, push them to Singapore, push them to US East, push them to US West. And when somebody makes a request, it comes from those locations. So we're reducing the effect of the speed of light on the distances that our requests have to travel, which means our users get a faster, more responsive app experience. And progressive web apps basically compose of three things, right? They're reliable, they're fast, and they're engaging. Reliability refers to sort of what happens when the network goes down. What happens when you're on sort of shoddy Wi-Fi? What happens when you go onto a plane, want to do something, and then get off the plane? What happens? Fast is when you're on, shoddy Wi-Fi or something like that. How fast can the application actually get sent to you? And then engaging means something along the lines of like using other web push notifications and other APIs like that to make a more of a richer app experience. But we're not quite there yet, and not everybody is using these. And even if you look at the people using service workers today, it still gets messed up a lot. And if you mess up something like a service worker and you don't have a way to sort of remove that service worker, you're in a hole. So these APIs need to get a lot simpler for us to be actually using these all the time. And on top of that, if we look at progressive web apps, right, and we say, what happens when the network goes down? It's nice to have the static assets around, but how do you then actually perform operations on your data in a way that when somebody comes back online, it all just goes up and syncs with the rest of the cloud, right? And the answer to this is a number of different things, right? But one of them is conflict-free replicated data types, or CRDTs. And people don't have access to these by default. And you can tell that because I had to go to Wikipedia to find an image to give you for what CRDTs are and how they work. Nobody's built these into like a React higher layer, right? Which is unfortunate because CRDTs are the way that we can use, or if we had CRDTs in everything that we built, we could make it much easier to support offline data access patterns. So here's your super fast intro to CRDTs if you have never seen them, because I assume that most of you have not, and I cannot see you. So I'm going to go over it. Imagine you have a JavaScript set. So if you've worked with a JavaScript set is basically an array, but every item can only be unique, right? So if you have 1 and then you put another 1 into the set, you only have 1. So imagine set A is on one computer and set B is on another computer. Both users have loaded your application. Both of them go offline at the same time. User A then adds 1, 2, and 3 to their set, and user B adds 3, 4, and 5 to their set. And then they both come back online, and they both try to sync at the same time. And what happens? Well, if you aren't using data structures like this, what might happen is one user writes, it hits your database, it gets stored, the other user writes, and then their write wins, or it gets denied, right? Either one of those two is a valid option, but like, you don't get both people's data. You have to tell one of them that it failed, or it silently fails. So the way that CRDTs work is when both people come back online, in this case, we'll send both sets to the server or send them to each other. And as long as we send all of the changes, all we have to do is this merge operation, this one merge operation, which is just creating a new set from all of the items in each of the other two sets. And this is what's called a grow-only set. So it's good for basically thinking of it as a series of light switches that you can only turn on. So we've turned 1 on, we've turned 2 on, 3, 4, and 5, right? So we don't get duplicate 3s, and we keep everything. The only restriction on this is that you can't delete anything. Which brings me to sort of talking a little bit more about data and how we fetch it and how we keep it around and how we sort of access it, right? And historically, we used REST, right? And REST came out of the backbone, or it didn't come out of backbone, but REST was sort of like the frameworks at the time were built on top of REST, right? Backbone supported REST as a first-class entity. The URL here is /books. It just gets you all the books and sticks them into your backbone model, and then you go off and do whatever you want with your application. And we've moved on since then to GraphQL, right? And GraphQL is quite nice as a query language. It's quite nice as a server. And people are starting to put this on serverless functions, which is really interesting because serverless functions means that we can push things all over the world to the user, right? And we don't have to worry about the operational overhead of actually running a server. There's a bit of a problem with some GraphQL features today, right? Specifically, like the Apollo library that we were just looking at. If you look at the Apollo subscriptions library, it's a little bit complicated, and it's not easy to implement. And if you implement it, it still might not be exactly what you need, right? So if we want real-time collaborative experiences, we kind of have to get better at doing these kind of things. And like I said before, everything's sort of getting pushed to the edge, right? As we think about Jamstack and we think about pushing our static assets to the edge, and we think about, okay, how do we do the same thing for our APIs? How do we do the same thing for our data? And what we can actually do is, if you're using something like serverless, we can use basically edge deployments, right? So there's Cloudflare workers, there's Lambda at edge. I'm sure that there will be more coming up in the near future. But basically what this is taking your GraphQL API and your database and moving them to US East 1 and US West 1 and Singapore and other places, right? So when your users from those locations access their data is closer to them than other people. So it comes back faster, right? Which brings me to the sort of the final segment of my talk, and that's meta frameworks, right? We talked a little bit about JavaScript, and JavaScript has come a very long way. Talked a little bit about bundlers, and bundlers have also come a very long way. And we're sort of maybe going back a little bit now that we have better experiences in the browser. And also how we treat our users and where we deploy things and how we deploy things and how that affects our user experience has also started to come a long way, right? And none of us really like doing Webpack ourselves. None of us really like doing Babel ourselves. And Create React App came out as a result of that, basically, right? Nobody wants to reconfigure all the same Webpack stuff for every common app that they ever do, right? So create React app abstracts over Webpack, Babel, any other dependencies you want, TypeScript, etc., right? Unless you get started building single-page applications or progressive web apps much faster. But if you look at Create React App, there's still a lot missing, right? Like Create React App doesn't have support for serverless functions. It doesn't give you any data abstractions. It doesn't give you plenty of things, right? There's more that we can do. And there are other meta frameworks out there now that are at a higher level, right? Next, for example, lets you deploy each page to a Lambda via an opt-in config option, right? So Next also does everything that Create React App does, and also integrates serverless functions into the whole ecosystem, right? Which is really nice. And then there's other meta frameworks like Gatsby, right? That take a slightly different focus. Like whereas Next is focused on dynamic server-side rendering and serverless functions and et cetera. Gatsby is focused on static sites and how do you pull all of the data that you want from the servers that you don't want running at runtime into a site and then use them via GraphQL to actually render out your static site, right? And Gatsby is also missing a bunch of stuff, right? Gatsby is missing any client-side helpers, right? So you don't get anything if you try to build a client-side app with Gatsby. In fact, you have to do a couple of things to sort of reverse some of the things that Gatsby does. You don't get serverless functions with Gatsby. Like you get those with Next, you don't get them with Gatsby. And they don't really give you any runtime data abstractions, right? So we get these nice build time data abstractions, but we get nothing in terms of accessing what's called our content mesh at runtime. And there's no reason that this has to be locked into just Gatsby, right? Somebody could build a content mesh like onegraph is kind of doing, and then you could access that from any site. So none of these meta frameworks today are perfect, and no meta framework will ever be perfect, right? But that's really what I want to talk about today and what I'm coming to a conclusion on right now. So what am I saying the future should be, right? The future could be serverless GraphQL at the edge with subscriptions, right? The future could be meta frameworks with data APIs that include first-class CRDT support, enabling our applications to be local first, offline capable, and collaborative by default. Like that could be a possibility. We could do that. Somebody just needs to step up and do it. And then like, and then Jamstack sites can be hybrid, right? We don't just have to choose static or dynamic server-side rendering. We could use both, combine them into a build tool, and then ship it based on ES modules, right? We have the power to do that now. And yeah, that's where I think comes next.
Dope. Thank you so much, Chris. So yeah, go ahead, give it up for Chris. And hey, Chris, do you have any time for some questions if we have any?
Yeah, I have some question time.
Cool. Do we have any questions? Me and Ryan will run over to you if you have anything.
We're very fast.
Mainly just Ryan. I just watch him run. Okay, cool. I have a question. So Chris, for you who has been through, kind of all of these transitions, what do you think has been the most exciting thing in, that has come into your, your repertoire, your toolkit, out of the things that you discussed?
Ooh, the most exciting? I don't know. Modules were super exciting when they came out, right? Like CommonJS was a big deal. Yeah, I mean, today I might choose something more like serverless, because serverless is super interesting. It allows like people who write JavaScript in the same way that Node enabled people previously. Serverless functions enable people who write JavaScript to just write a function that takes some arguments and returns something and have a database, right? Like that's extremely cool.
I was gonna say, if you didn't say serverless, me and you were gonna have issues for how much you talk about it.
Hey, man.
Cool. Yeah. So no questions?
I got a question.
Oh, that sucks.
Yeah, I know. Hey, Chris, sorry to keep you. So we have, our community has people from all sorts of experience levels, ranging from getting into the industry up to expert. I was wondering if someone was newer to development and they wanted to, build a small CRUD app, like a to-do app or like a meetup app or something like that. what would you personally choose to use right now and why? And maybe that can help inform some of our friends here if they're looking to build some side projects.
Yeah, I think that if you're trying to build, if you're sort of at a beginner level, you know some React, right? Because you're at a React meetup right now. And you don't really know much about like Next or Gatsby and like why you would use either one of those. I would probably stick with Create React App. I would probably stick with something like Netlify Functions. And then you get to choose whatever data store makes the most sense for you, right? Whatever you have experience with, if it's SQL or if it's something more like DynamoDB. But you can get the client-side app deployed on Netlify, right? You get the functions, which can also be deployed with your client-side app on Netlify, which makes everything fairly simple. And then basically the only other option you need to make a decision on is where am I going to store this data?
Awesome. Thanks, Chris. Does anybody have any questions before we let Chris grow? We have him for like 2 more seconds. Okay, cool. I think that's it, Chris. Thanks so much for joining us. Really
Thank you, dude.
Let's give it up for Chris, everybody.